We're gonna get started. So we appreciate everybody coming down here. We appreciate everybody's time. So for those of you who were here 2 weeks ago and even 3 weeks ago, so we've done mental health and construction, suicide awareness, and then 2 weeks ago we did fall protection and fall rescue. So this week we're doing confined space entry safety. We have Derek from MSA here. We use MSA air monitors for checking our confined spaces when we open a barge hatch, etc. It's their air monitors that we've switched over to. So we had the old yellow air monitors that we've used. We've switched to the MSAs. They're, in my opinion, they're a better product. So it worked better for you guys. So to me, it's important that we train you guys a little bit better on how to use them. It's a good refresher to do confined space entry as well. It's a good hands-on. At some point after Derek's done, we're gonna go down to the Redemption, and we have some new equipment out there. The equipment out there, we rented at some point down at Coleman, but now we own it. So we're gonna open one of the larger hatches, and if I can hopefully get a volunteer. Oh, Jimmy's raising his hand, perfect. Appreciate you volunteering to go down into that hatch for me. Put you in a harness and lower you. We're gonna actually lower you down into the hatch. With the equipment we have, we did the same type of thing with one of the perimeter limiters out at Lopez doing washout on-call work. The davit system that we have would have been more ideal, but at the time we didn't have it. It was short notice, so we used the perimeter limiter. This equipment that we have 3 different base options now, and there are more available. There's other ones, there's like weld-on and bolt-on options as well, but the one we have is, the 2 of them we have are freestanding. The one you'll see out there is called an H-base. It fits around hatches, etc. There's one that they have down at Coleman that they were nice enough to fill with concrete for us. It's a freestanding base. It's an offset, so you could set it on the edge of a dock or a pier, and you could actually use it to work down over the face of the edge. We'll talk about it when we get down there, but there's a 3-way, which is a yo-yo, but it also works as a winch to raise and lower. And then we also have a winch on the davit that can be used to raise and lower either people and or tools. So it's all stuff that we'll talk about when we get down there. But before we get down there, Derek is here, and he's going to talk about just kind of the basics about confined space entry, but he's also going to go over the air monitors. For whenever you guys are out on a job and you take an air monitor out, instead of having an air monitor just floating around on a barge and a charging base, you're taking one of these out with you now. And this air monitor case has everything in it you need for, or you and the crew needs for maintaining your air monitor, doing your bump tests, etc. It has a bottle of calibration gas for doing your bump tests. It has a regulator. There's 2 different styles, but it doesn't matter which one you have. Either it'll be this big steel one or this aluminum one. It doesn't really matter. They both function the exact same way. There'll be a little piece of hose for doing the bump. There's a charger in here. The monitor itself fits in here. There's a hose that's 16 feet, 20 feet?
10 feet.
Oh, 10? I don't know. And then the wand itself for when you're lowering down inside the space. So we had all these cases custom cut for the equipment, so you're not having to try to figure out where the stuff goes. We did some of the other cases where you pull the material out and they just fall apart over time. Since these are custom cut, they're specific. It's really easy to pull the monitor out, drop it back in where it goes. Super easy to manage. Just let us know when you guys are going out, or if you need a monitor either here in the yard, out on a barge, etc. We've got 8 air monitors and cases to go with them, calibration gas, etc. So just need to have a heads up that whatever your list is, like you give to the yard for tool list. Can we add that to the tool list for that you guys do, and then we'll just add one of these to it? Okay. So I'm gonna pass it over to Derek and let him do his thing, and I'm gonna go get some other stuff set up.
All right, sounds good. All right, good morning, Derek Edwards. I'm with MSA. We're the company that manufactures this equipment. So we're just gonna kind of run through all of the items that Matt just talked about, some of the use, limitations, that sort of stuff, and how to use each piece of the equipment. So the first thing we're gonna talk about is the gas monitor itself. This is a 3-button operation on the instrument. Instrument is off now. To turn the instrument on, we simply press the middle button and it'll start beeping. Some things will come up on the screen. That's how we know that it's starting to warm up. There is a warm-up sequence to this instrument before we can use it. Pump will start running. There's an internal pump inside here that's pulling through this little port on the back side here. Now the first thing that's going to happen that might alert you is that it's going to go into alarm, and you're probably going to think there's something wrong with the instrument. There's nothing wrong with the instrument. It's asking you to do a test. It's a pump test. So now we're in alarm. So now what we're going to do is we're going to take our finger and we're going to block the inlet. So it beeped 3 times and now it's going to go on about its business. So what you did there, or what I did there, was I checked the integrity of that pump system. So if we had a leak in that system, it would have not passed that test because it sucks up tight, passes the test, and then moves on. Okay? In a little bit, I'm going to talk about the sample line and probe. I'm going to connect all of this up. If we're pulling a sample, which typically you're going to pull a sample with the sample line and probe connected to the instrument, okay, that means that your sample system goes from this pump all the way to the end of the probe, which means we need to connect that system before we start the instrument, and we're going to block the end of that probe, and I'll show that to you. Little preview for you. The important thing here is that we block the end of that, because if we have a leak in that system, you're not pulling a sample from the end of that probe. You might have a leak, which means you're getting diffusion and you're not checking the bottom of that space because we have a leak in that system, okay? So the instrument has all warmed up. Well, it's almost warmed up there. We got a little green bar on here that's moving along. There's a bunch of numbers that are going to come up that are really meaningless to you. It's basically the alarm points that the instrument's going to go into alarm. It's the calibration gas concentrations, a bunch of fairly needless information. Again, you don't need to pay attention to. Eventually it's going to warm up and you're going to be on the home screen and it's going to show all 4 gases. So this instrument here is checking for oxygen levels, combustibles, anything that goes kaboom, carbon monoxide, okay, typically from a combustible engine, and hydrogen sulfide. Those are the 4 gases. You also have this same instrument, but it has an additional sensor in it. It's a PID, and it is checking for volatile organic compounds. So it might look a little different. You need to talk to Matt. I'm not sure when you guys would use a 4-gas instrument as opposed to a 5-gas and how that would work, but it might look a little different with a VOC sensor, okay? So we are up and running. Each one of these sensors has an alarm point, so if we have some CO in the space and our CO levels go up to a certain point, it will go into alarm and tell you, okay? We can look at the screen. If you're in the space, we want to vacate the space, then look at the screen to see exactly what it was. So I'm going to breathe into this instrument, okay? I'm breathing in oxygen. Right now we're at 20.8, and if you look at this screen, it says 20.8 oxygen, okay? I'm going to breathe into this instrument and send it into alarm, because I breathe in oxygen in my lungs, in my body. It turns it into CO2, carbon dioxide, and it's going to send it into alarm just so you guys can hear and see what it looks like. So now my instrument is in alarm, tells you it's nice and loud, it's also vibrating. I can look at the screen and it's telling me it went down to about 17.5. Eventually, this alarm will either clear if it went into low alarm. If it went into high alarm, which it did, I need to look at the screen and the screen says reset. I press the right button to reset the alarm, and now it is back in good working order, okay? So that alarm was recorded in the instrument, okay? These are little black boxes, much like would be on an airplane, okay? If anything happens to this instrument, something just happened, it's recorded in there, and now it's in the instrument. That data will get downloaded when the instrument goes into the docking station, goes into a software package. So if you do have an alarm, understand that that alarm is recorded in here. If we have an injury, fatality, accident investigation, that sort of thing, all of that stuff is inside here. Okay? There's a couple of buttons you can push on this instrument to see information. Okay? The right button is our mode button. So if we look at the instrument, it says bump just above the left button there. If we press that, we're going to do a bump test, which we'll do in a second. If you continue to press that button, it's going to continue to show you information. One of those buttons, or excuse me, one of those pieces of information is the alarms, okay? Push it twice, it's going to show the peak reading, which is the highest level of alarm that it's seen since you turn the instrument on. You press it again, it's going to show you the minimum screen, which is the oxygen level, okay? I just pushed it twice and it shows me that my oxygen level went down to 18%. Okay? If we continue to press that button, it shows us the date and the time and a bunch of other information that you really don't need. But if you have an alarm, just remember, push the left button. That's going to tell you what sensor went into alarm and how high or low that alarm was. That's important information because if it was CO, now we know we have CO in the space. We need to ventilate, get that out of there. If it's oxygen, again, we need to ventilate, introduce oxygen into the space. Okay? Other than that, really don't need to push the buttons on the instrument except to test the instrument, which we'll do here in a second. Okay? 20-hour runtime on the battery. On the screen, it shows a little battery, just like your cell phone. It will disappear over time. But we do need to keep the instruments charged while they're on the boat. Takes about 2 hours, 2.5 hours to get a full charge into a completely dead battery. All right? Any questions on the instrument? Good, good, good. All right. So as I mentioned, we have sample line and probe here because we need to test. We always test the space before we go into the space. So this is a 10-foot line. We do have 20-foot lines, and you can also connect two 10s. So if your space is 15, 20 feet deep, this line is not going to be sufficient to test the bottom. So we always start our test at the bottom, and we test about every 3 feet in a confined space to pull a sample all the way down and all the way up. That's important because different gases have different molecular weights. Some will sit at the bottom, some will come up to the top. So just because you drop this in and test the bottom doesn't mean that the air is good in the middle or at the top. So we have a quick connect that goes right to that port on the instrument that I mentioned earlier. Lock that on. Instrument may go into alarm because we have put an additional pull on the pump in the instrument. Not a big deal. We look at the screen. We press the right button where it says reset, and it continues to work. Again, a quick connect on our probe. And now we are pulling a sample from here. Remember I mentioned earlier that if we are pulling a sample, which you typically are, before you turn the instrument on, connect this up so that we can test the whole system. I will now block the end of this, it's going to send our pump into pump alarm. So if I drop this into a space that's got water at the bottom, it's going to block that sample system, and this is what's going to happen. Or if we kink this hose, we simply, again, read the screen, we press the right button, it says reset, and we go back to work, okay? We try to keep water out of these instruments for sure, and definitely out of the end of the probe. Inside this probe, probably can't see it, is a very small replaceable water and dust filter, okay? If you put this into water, that is going to stop the water from going through the hose and into the instrument. If you fill this up with water, it needs to be replaced, okay? Hopefully you have some extras in your case. I'll talk to Matt about that. But you're going to want to replace that, because if it gets full of water and then you clear that pump, it's going to go right back into pump alarm because it can't pull a sample through all of the water that's in that filter. So that may be the problem. Additionally, on the back of the instrument here, probably can't see it, but there is a secondary filter underneath that inlet right here. It's a little white filter about the size of a nickel. Over time, that can get dirty. It's replaceable. But if you see water droplets, this is a clear housing so you can see it. See water in there, 2 screws here, open it up, just let it air out. You may or may not need to replace the filter. Let it dry out, put the 2 screws back in there, and you'll be good to go. But that would be a secondary filter, and this is our primary filter. During our confined space operation, first thing we're going to do is we're going to test that space. We're going to drop this down to the bottom of the hole, and we're going to pull a sample from the bottom, okay? There's 10 feet of sample line here. We're not going to be able to just drop this down, wait 3 seconds, and then pull it up 3 feet, wait a couple seconds. It does take time for this monitor to pull the air all the way through the tubing to the instrument for the sensors to read it, okay? So rule of thumb, 10 feet, 1 minute. Drop it down, wait 1 minute. You can look at the screen. It'll go into alarm and you'll be able to hear it. Pull it up 3 feet, wait 1 minute. Up 3 feet, 1 minute. Till we get all the way to the top. Okay? Any questions on the sample line? Good? I don't know if you were here, but I mentioned extra filters in the case too, as well. Okay. All right. Good, good, good. All right. Next, we will go over a bump test for the instrument. It is important that these instruments are tested before you use them. And without going into too much detail, I will just tell you that a bump test with calibration gas is just a check to see if the instrument is reading correctly. If the instrument's not reading correctly, it may go into false alarm. It's not going to be an accurate reading. We want to make sure that we're accurate. So to set up your bottle, you simply screw the regulator on. You're going to have a calibration hose here that may or may not be attached to the bottle. You're going to attach that on there. You'll recognize this is the same connection that we had on our sample line. It's a quick connect fitting, okay? So before we do a bump test, we want to make sure this is all set up just like this, because the instrument will time out when we put it into bump mode. And if you're scrambling to get it all together, it'll time out and you'll have to do it all over again. So get this ready first so you're ready to go. So again, we look at the screen. It says bump on the left side. We press that button and it asks us a question. It says bump test, question mark, yes or no. We are going to say yes, which is the middle button. We press that. And now it says bump test and it's flashing. You don't need to push any more buttons. We simply apply the gas. This regulator does not have a knob on it. You can't turn it on. It's called the demand flow regulator. Gas is now flowing to our instrument. And in about 10 seconds, it's going to beep 3 times. You can't see it, but there are 4 check marks on here and our bump test pass. Now we know this instrument is reading correctly and ready to be used. Something else happened to this instrument. You can't see it, but there is a very small check mark at the top of this instrument. That check mark will only appear if a successful bump test or calibration has been done. So the training point, really important here, we only use an instrument that has a check mark. So if an instrument's sitting on the table, you walk in, hey, we're ready to go to work. Has this instrument been bump tested? I don't know. It's really easy. Look at the top of the screen. There's either a check mark there or it's not. Check mark, use it. No check mark, it needs to be bump tested just like I showed there. Did you want me to do a calibration as well?
No, I think we're good.
Okay. Good,
so,
good.
Derek just asked about if we wanted him to do a calibration. If a instrument needs calibration, let us know and we'll bring a new monitor to you. We have a whole pile of them sitting here. We'll swap it out. We'll do the calibration here in our office on the calibration station. That way I can track them electronically. So that way we know when calibrations are done. And then we'll just bring you a new monitor, take the old one from you. If you're out on a job remote, we'll fly out to you, bring you a new one, ship it to you, whatever it takes. That way we know that you have the most current calibrated monitor. I need to bring one up to Alaska this week to do that. So it's part of the process. So.
Okay.
Okay.
All right.
Let's head down to the redemption.
Let's do it. All right. So this space here down to the bottom is going to be more than 10 feet. So I'm not going to be able to test this effectively in the way I should with this, but we're just going to kind of pretend. We would need a longer piece of tubing, and that may be something to consider, Matt, getting some 20-footers or whatnot. And as I mentioned, we can connect two of these lines together, not more than two. So if you have a 10-footer and a 20-footer, we can make 30 feet if we need to. But first thing we're going to do is we're going to send this all the way down to the bottom. And I will say too, gases, explosive gases, acetylene, methane, those sorts of things are lighter than air, so they tend to come up to the top of a space. So if you can, and there is space to test underneath the lid or a manhole type of a situation, always a good idea to send this underneath and check to make sure that there's nothing at the top, okay? Particularly if you're having to pop a lid. This is more utility work, manholes and that sort of thing. There are lots of incidences across the country where methane sitting at the top of a manhole, they go to crack it, creates a spark, boom, okay? So if there's a possibility of that, never a bad idea to check the top of that before we crack if we have a hole or a way to do that, okay? But here we are. We go ahead and send this down all the way to the bottom. We would then wait 1 minute, okay? We're going to pretend it's been a minute, and then we would pull that up about 3 feet, wait a minute, 3 feet, wait a minute, all the way to the top, okay? Now, there's one of two things we can do when we put the worker into the space, all right? If our worker is going to be working right down below, I can see him and I can run this sample line right near where he is working. I can leave this instrument topside with me. I'm the attendant. Here's our entrant. I'm the attendant. I'm watching him, which is required that we have an attendant. I can set this right here in the space, watch it and listen for it as long as it's pulling a sample near where the worker is. If I can't do that, if he's going to go in and go 10 feet that way, 5 feet that way, whatever, we do need to monitor that space all the time while the worker or workers are in the space. So what I would do is disconnect this. I would come over here and I would pop this on my worker right there, just like that. Now this is pulling a sample. I'm actually going to turn it around here. We have a belt clip on the back of this thing. There we go. Now, that's pulling a sample everywhere he goes, sort of in his breathing area. When he gets down there, if he wants, if he's staying in one area, he can set it next to him. He can take it off if this is kind of in his way. But it needs to be in the space in case something changes, so it will pick anything up. Now, if I've got a space where I'm sending somebody 10 feet that way, 10 feet that way, really each one of them should have an instrument testing that space, because the air quality over here is not going to be the same necessarily as it is over there. Okay? There you go.
So the harness that he's wearing is a specific harness that is for confined space entry. So he has D-rings on the top of the shoulders that allow him to be lowered into a hole. I think some people saw, like especially the guys that were up on on-call work out at Lopez, we had a harness that had a chest D-ring and a front waist D-ring that allowed us to lower Ryan down into the floating pontoon at Lopez. It was essentially the same scenario. We had a winch and we had a retractable. This retractable works a little bit differently than the scenario we had there. This retractable also allows us to raise and lower a worker. So it works the same as a regular retractable. It stops like a yo-yo does. It's hanging, it's positioned differently. It's upside down here in this scenario. And then we have the exact same winch as the perimeter limiters do. So it's raise, lower, just the same as we did before. We can also freewheel with it. And then with this, so we have trauma straps just like we had 2 weeks ago when Jeff was here doing the jump off or lower himself down with the self-rescue situation. The advantage of this is that he's not gonna squish everything with his harness as bad as it would be. So in this scenario, we have this yoke. There's two different versions of this yoke. This version keeps the harness off of his head. It separates it. There are scenarios where the yoke doesn't actually fit through the hole. So we have a yoke that looks like this. It doesn't have a spreader in it. So we bought both versions just in case, depending on what the work is, what the access is. If we have one of these little tiny holes and we didn't have a ladder, the ladder was broken, whatever the scenario is, that gives us two different points of access. And then up at POA or up in Anchorage, they have the exact same equipment. They have a different base for the davit, but they have the same davit, they have the same harness, same yokes. The base that I talked about that straps to the side of a pile, they have the same bases. They have two of them as well. So we have lots of different tools. They have the same winch, they have the same retractable. So we have tools both in Alaska and in Washington to be able to move about wherever we need to. If we need more davits, but we have enough bases, we have enough whatever, we can rent additional depending on the job, depending on the work we have going on. So, lucky you, I am going to hook you up to this yoke. So in this scenario, I'm gonna be able to raise and lower him. We actually have we have one more piece that's on super back order. It's 21, it'll raise this 21 inches further. This is adjustable in a bunch of more capacity. I'm gonna raise this up a little bit more just to give myself a little more height so that you're not. These tools give us a lot of flexibility. Hopefully take out as much of that height of that yoke as I can. There. But so the thing is, just like with the fall protection scenarios, we want to make sure we have fall protection at the same time, not just the ability to raise and lower. So the way this is set up is that he could theoretically, just like with the perimeter limiter, step over the edge and hang. So I want you to step over the edge and hang. And then step into that trauma strap so that you're not squishing yourself. There you go. Put both feet into it. So take the strain out of your groin. So there you go. So the advantage of this davit is by myself, I can position him into this hole wherever we need to. So in a scenario like up in Anacortes, if we need to get down into the manhole, I think it's 20 some odd feet deep, we have the ability to do so. And I can lower him down relatively simply at whatever pace, however fast I want to or need to. And I could do this with the winch, or I could do this with the retractable. I'm not going to make him go all the way down, but it's important that you guys know what tools we have, and then we show you how to use the tools, because there's no point in us buying a bunch of tools and then not showing you guys how to use it. And then if we're ever on a job and we need to use these tools, you got spun up. We're not going to send you out with a set of tools. I'm unspinning you. Here, we're getting twisted up. There you go. We're not going to send you out on a job with a set of tools and then not show you how to use them. So we'll take them out to the job site, just like when we got perimeter limiters. All right, you can go ahead and step out, swing off. There you go. So we will make sure that when we go out to a job, we take tools out to you, that we show you how said tools get used before we say go. And we're gonna make sure that both the crew is comfortable and the safety department is comfortable with you guys using the tools before we leave. So, does anybody have any questions on any of this stuff? How to use it? Yeah. What's that? We have one of this in Seattle and then one in Anchorage. And we have 4 different bases in Seattle and then 3 different bases in Anchorage. From an anchor point perspective, it's 5,000 pounds. The winch is good for 350 pounds for raising either people or tools. So it's actually really simple. So you can take the harness off if you want. Make life more comfortable. What's that? Nope, it's completely freestanding. That's it. That's all the pieces to it. So breaks down to 5. It's a 5-piece davit system. So I carried both of these pieces out here, and then I carried this and the winch out here. Matt carried the davit and the retractable out here. So 3 trips out to the barge for one person. It all fits in the back of a pickup truck. Even our short bed trucks with a slip tank, they still fit. So it's a relatively small package. If a job needs it in a hurry and they're local, we can throw it in a pickup truck. Could probably even squeeze it into CRV if we had to. So yeah, it's mobile, it's easy. Coleman's got the other base that's quite a bit bigger that would need to go on a trailer on the flatbed. It's 4,800 pounds or something with concrete in it. But the advantage of that is we could set it right against the edge of, on the edge of something, on the edge of the barge, on the edge of the dock, whatever, and then the davit would be able to hang off the side. But so, anybody have any other questions?
When it's in dirt, like in a course and they're out in dirt, man,
Yeah,
do we have to put something underneath the leg?
just some plywood, just some pieces of plywood. Yeah, nothing. You don't need like steel sheet or you don't need. Yeah, but we don't need to put steel sheet down or anything. But in that scenario, we could use the concrete base also. That's probably easier. Yeah, and the concrete base has fork pockets from both sides. Plus, it has swivel hoist rings on top, so we can pick it up with a crane or hoist pack on the forklift. So, lots of different ways to be able to pick it up and move it. So, it's, as far as moving goes, it's functional. Anybody have any other questions? All right. Well, I appreciate everybody's time. Appreciate Derek coming out here to show us using the air monitor. And then appreciate Integrity coming out here shooting these videos for us. That's all I got. Thank you.